Okay, in this screencast, we're going to look at lesson 4, which is multiple representations of functions. This one is a little tricky, so we're going to take a couple of days on it in class, but right now I'm going to go over it real quickly in our notes, but we'll do lots of practice. So on this side, we're going to look at represent functions using words and equations. So we've kind of done this before. We're taking a lot of stuff that we've done and put it into one big, massive problem. And then we have to break it down step by step. So a runner's distance in a marathon is equal to 8 miles per hour times hours. So we have 8 times the hours. So distance equals 8t because we're multiplying. So that's what we did with this one. Let's take a look at this. The drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to the total amount earned for T for selling P pies. So, when we're looking at this, we're first going to break it down into the words. So that's what they're doing it right below us, right here. So we have 5 for each, so we're going to times. So 5 times P, 5 times pi, and we want to know how much they earned T. So T equals 5P. Here, a mouse can travel 8 miles per hour. Write an equation to find the total distance. So I'm just going to do right here. To find the total distance, D. So we don't know D, so we're going to do D equals how many times you can move per hour. So per, we're going to be doing multiplication. So 8H. We're just putting, ooh, sorry, you can't see any of that. So a mouse can travel 8 miles per hour. So 8 times H, remember 8, a letter and a number next to each other means multiplication. And then D equals 8H because those are the letters they told us to use. Down here, Samantha can make 36 cookies each hour. So that means we're going to multiply. Now let's figure out what variables we need to use. So we're going to write an equation to find the total amount of cookies, C, that she can make in H hours. Since we're trying to find C, we're going to have C equals 36H because they told us that's what we needed. So if Samantha was to bake for 4 hours, she would put 4 into H and do 36 times 4 because she can do 36 cookies in 1 hour. Let's take a look at this big, massive problem over here. We've kind of done bits and pieces of this throughout like the last chapter, so we're putting it together in a big problem right now. So this problem is showing us that we're going to deal with tables and graphs, and then we're going to analyze that and put it into our words of what's going on. So they're just showing you that when we have 0, 0, we're going to write an ordered pair of 0, 0. We start there. Then we're going to do 1, 8. So we run to 1, jump to 8. And then we're going to have 2, 16. So we're going to run to 2 and jump to 16, then our line goes up. That's part of it. When we get down here to the bottom, we're also going to analyze it. So we're talking about a bald eagle right now, because that's what it's telling us. So while in normal flight, a bald eagle flies at an average speed of 30 miles per multiplication hour. So write an equation. That's what we're doing first. In our equation, let's see, they're using H and D. If you look down here, is going to be D, because we're looking for the distance. So write an equation that make a function table show the relationship between the total distance. So D equals 30H. So that's our equation. Now we're going to take that equation and we're going to fill out this table. And we're always going to start with 1 because that's what we use to start to count with. So we're going to go 1, 2, 3. If there's more boxes, we can continue to go to 4, 5, 6, and so on. So now what we're going to do, this is H, so we're going to plug these numbers in. 3 times 1 is 30. 2 times 30 is 60. 3 times 30 is 90. So we wrote the equation. We have our function table. Now we're going to graph. So we have 1, 30. So 1, jump to 30. 2, jump to 60. 3, jump all the way up to 90. And we're going to put a nice straight line, as straight as you can get it, because we're going up. Last, we graphed. Now we need to analyze. The first thing we're going to talk about is we're going to write the graph as linear. When you're writing the graph is linear, that means it's in a straight line. It might be a diagonal line, but it's still a straight line, and it's going to continue to go in that way because we have a set equation that tells us that's going to continue to go there. So the graph is linear because it increases oops, sorry, I separated that word. The graph is linear because it increases by 30. And I know it increases by 30 because I can look in two spots to see that. I can see that it goes 30, 60, 90. That goes up by 30. Or I can look down here at the graph, 30, 60, 90. So we're going to write the graph as linear, and then you're going to tell me why. So it increases by 30 each time. Okay, make sure you're paying attention in class, doing some more practice problems with that if you need it. Check out some Khan Academy videos or other YouTube things.